functions, the procedures we use are not different from composition of functions. In all the functions, we substitute one function into another. Now, in composition of functions, the process is very direct, unlike in combined functions. And so, composite functions, the process is direct, while in combined functions, the process is not direct, as you are going to see. And that's what makes composite functions a bit different from combined functions. Let us look at these questions as we solve. As we solve, make sure you pay attention to the notations and what they mean when solving. So we have question A. Okay, so our question A, we want to find the value of x for which fg. Now here you need to understand what fg means. Okay, fg is the same as f of g of x when we are looking at composite functions. Now under combined functions, it is denoted as fg. So this means we are going to substitute the function g into f. Alright? Okay. Now this can also be denoted as f g x. Okay? This is very much different from multiplication of functions. Okay? So when we are talking about multiplication of functions, if that's the question, multiplication of function is denoted by f, right? It can be f. There you have a multiplication. That's f multiplied by g. Okay, and this would be inside the brackets, and there we're going to have x. Now this is how we denote a multiplication of functions. Okay, if it is not denoted like this, multiplication of functions can also be denoted by fx. Okay, there you have, then gx. Okay, so this is how you denote multiplication of two functions or more functions. So you must not mistaken combination of functions to multiplication of functions. Okay, so you need to understand what the notations, what each notation means, and what to do depending on the notation. So the notation you've been given tells you what to do to solve the question that you have. Alright, so I'm sure by now you're able to differentiate between multiplication of functions and composition of functions. Alright, so we can now solve the question that we have. Okay, so the question we have is fg, which is can also be written as fgx. Okay, so to solve this one, this question, we just need to follow the notation, what the notation means. So in this case, what this means that we have is that we are substituting fg, that is g, into the function g into f. Okay, so look at the functions that we have on top there. Okay, and keep in mind that what we are doing is combined functions. Okay, all right, so now what do we do here? We have fg. Okay, this fg will be equal to, look at the function f. Okay, the function f is 3 over 2x plus 1, right? Now we're going to substitute the function gx, which is 2x plus 3, into 3 over 2x plus 1. So if we do that, we are going to have 3 over, that's 2, right? You open your brackets, you're going to have 2x, you're going to have 2x, that's plus 3, right? So you close your bracket. So this, let's just extend this. Okay, then what else do you have there? You have plus 1, right? Okay, now this is what we have. So if we proceed, to that, what we are going to have is, so if you do that, we are going to have 3 on top there, right? We're going to have 4x. Okay, let me just show this as well. So we're going to have 4x plus 6, right? So we're going to have 4x plus 6 plus 1. Okay, so this is going to give us 3 over, okay, let me just extend this again. That's 3 over 4x, right? That's 4x plus 7 plus 7. So what we have here is the function, the combined function of f and g. Okay, so it is denoted by this. All right. Okay, so this is fg. Now the question is, okay, let me also include this. Okay, so we have found fgx. Okay, that is the combination of f and g. Now the question is, we need to equate this to 2 over 5. Okay, because we are assuming that this is equal to that. All right, so let's just create some more space here. Okay, let's just create some more space so that we can have enough space to solve. So if now what we have, which is fg, okay, that's fgx. Fgx, we are told fgx is equal to 2 over 5, right? 2 over 5. Now what this means is we are going to equate 3 over 4x. Okay, that's 4x plus 7, because this is what we have. Okay, plus 7 is equal to 2 over 5. Okay, now solving this is going to give you, okay, now if you do this, we are going to have 8x, right? Okay, you're going to get 8x plus 14 is equal to 15, right? Okay, so this is going to give you 8x again. Okay, that's 8x is equal to 1, which will give you x is nothing but 1 over 8, right? So this is what we are getting. So this is the solution for our first question, that is question A. Okay, now we can go to B. Okay, so in B, here we are told that fx, okay, we're told that the function fx is equal to gx, and then we need to find the value of x. Okay, so how do we do that? How do we find the value of x given the situation that the function fx is equal to gx? Okay, so this is what we have there. So to solve this question, we are going to substitute. Okay, we have our function fx. Now you can take your function fx, which is nothing but 3 over, okay, that's 3 over 2x, right? That's 3 over 2x plus 1 is equal to, now gx, you need also to substitute there. Your gx is 2x, okay, plus 3, right? Now solving this is going to give you 2x, right? That's 2x plus 1, 2x plus 1, there we have it, multiplied by 2x, okay, plus 3 is equal to 3, right? Okay, so this is what we're going to have. Now if you multiply, okay, if you multiply, you are going to find that what you are going to get is 4x squared, right? You're going to get 4x squared plus 2x. Okay, so let's just go this, plus 2x plus 6x, right? That's plus 6x and then plus 3, which should be equal to 3, right? Okay, now if you simplify here, we're going to get 4x squared, right, plus 8x plus 8x is equal to 0. Okay, now if you solve this, you're going to get x, right, is equal to 0, right, or x is equal to -2, right? You're going to use factorization method here. Okay, so when you factorize 4x outside, inside the brackets you are going to have x plus 2, right? So solving for x, you are going to get x is equal to 0 or x is equal to -2. Okay, now we can solve the last part. Okay, now look at the last question. I want you to pay attention to this notation, okay, to this function notation. This function if you are not careful, you can look at this and conclude that this is multiplication of this is composition of functions, but that's not the case. This one is now multiplication of function from the explanation that I gave you at the beginning of this video. Okay, so we know that this question we are multiplying two functions, that function f and g, right? Okay, so we can do that. So make sure you take note of the differences, okay, between being asked to find the combination of two functions, the multiplication of two functions. Okay, yeah, those are very important points to keep in mind. Okay, so this one we are going to multiply. So we have our function f, which is 3, right, over 2x, that's 2x plus 1 plus 1, right? We are multiplying. Okay, so we can just use brackets, I'm sure. Okay, so we can do that. Now if you do this, our function gx is 2x plus 3, right? That's gx plus 3. So this is 3 there. Okay, now if you multiply your functions, what you are going to get is just 6x, right, plus 9 over, okay, you're going to have over, that's 2x plus 1 plus 1. So this is what is your f g. Okay, so this is the product of your function gx and fx, or fx and gx. Okay, all right, so this is how we solve. Now let's